Good morning to all. So, this is Selumar from SNS College of Technology and from Department of Computer Science Engineering. So, now I am going to tell about memory management unit in background concept. In a memory management unit, consider some kind of types. It is called as a background and a swapping and a contiguous memory allocation and segmentation, paging, and structure of page table. So, now we are going to see about what is a backgrounds in memory management. So in a background, so the program must be brought from a disk into memory, so and placed within a processor for it to be run. So in the background, the main memory and the registers are only storage, and the CPU can access directly. So in a background, the memory unit only sees a stream of address plus a read request or address plus data and write request. So in a background, the register access in one CPU loop clock, and or else the main memory can take many cycles, causing a stall and a cache. So in a cache, site sits between main memory and the CPU registers, and the productions of memory required to ensure correct operations. So in a background we have a base and a limit registers. So a pair of base and limit registers defines the logical address space. So the CPU must check every memory spaces generated in a user mode. To be user, it is between a base and limit for that user. So in this diagram we have a operating system and a 3 processor. So we have a 0 to 1,24,000 is the address space. So we have 3,40 is a base limit and 1,20,900 is a limit. So whenever we have to use this limit, we have to enter this address in this base and limit address. So we cannot use other than the limit addresses. So this is a hardware address protection for this base and limit address. So when we are going to use any files from CPU or from a memory, so we have the address is translated to the main memory. So the address is considered as greater than or equal to means the base is added to limit and then sent to memory. If less than means it is directly trapped to operating system monitor and is addressing error. Then the base plus limit it is less than means it is address is less than means it is sent to the main memory, otherwise it is sent to the addressing error. So address binding in a background. So program on disk ready to be brought into memory to execute from an input queue. So without support must be loaded into address of 0000. So in address binding, so inconvenient to have a first user process and a physical address always at 0000. So further, the address represented in a different ways in a different of programs. Like for example, source code address usually symbolic, and compiled code addresses bind to relocatable addresses, and link or loader will bind relocatable to absolute addresses, and each binding maps on address space to another's. So address binding of instructions and data to memory addresses, it can happen at three different stages. So one is a compile time, and the second is a load time, and third one is execution time. So in a compile time, so if a memory location is known as a prior absolute code and can be generated, must recompile code if starting a location changes. In a load time, so it must generate a relocatable code. So if a memory location is not known at a compile time, execution time, so binding delayed until runtime. So if the process can be moved during its execution from one memory segment to another. So and also it need a hardware support for address map, example of base and limit registers. So it is a multi-step processing of user program. So it is a source program to in a memory binary memory in a memory binary image. And so in a compiler for a assembler and a object module and a linkage editor and a load modules. So we have a three different compile time and a load time and a execution time in this concept. So logical is physical address space. The concept of logical address space, that is bound to a separate address space. It is a central to proper memory management. And a logical address is generated by the CPU. It's also referred to as a virtual address. So in a physical address, the address seen by the memory unit and the logical and the physical address are the same in compile time and the load time. And also it is going to use the address binding schemes. So logical and the physical address is different execution time and address binding schemes. So the logical address space is the set of all logical address generated by a program, and the physical address space is the set of all physical address generated by a program. So in a memory management unit in MMU, so the hardware devices that at runtime maps are virtual to physical addresses. So we have many methods possible in a memory management unit, that is called as to start and consider simple schemes where the value the relocate and register is added to every addresses. So and generated by the user process at the time it is sent to memory. So we have a used called as relocation register. It is a base register now called as a relocation register. The user program deals with logical addresses, so it never sees the real physical address, because when we are going to use about execution time, the binding occurs when the reference is made to a location on memory. So the logical address bounded to physical address space kindly. So this is the dynamic relocation using a relocation register. So the better memory space utilization and unused routine is overall order. So we have a CPU and a memory. So logical address 346 and the physical address is relocation register is 1400 14,000. So the physical address is 14,346. This is the exact address and is holding in the main memory. So we have for dynamic loading. So dynamic loading is loading routines of node identity is called. So it is a routine kept in the disk in a relative load format. The main program is loaded in the memory. So it is executed when routines need to call another routine. So the calling routine first checks to the other. This is dynamic loading. So we have a static linking and in a systems libraries and the program code. So compared by the loader into the binary program image. So dynamic linking linking postpone until execution time. So we have small piece of code called a stub, and then this is a system also known as a shared library. So every system is in a shared library. Operating system is routines in a process of memory address. So dynamic linking is particularly useful for libraries. So the consider applicability to patching system libraries. So this is my reference for memory management in the background. Thank you.